And girls, this is basically an overview of SLT number 3. So the first thing you have to learn in this is, so how would you ever construct a tangent? And just a reminder, to construct a tangent, you would have to draw a line that goes either to the circle or you could, I guess, extend it. And where this hits, you'd basically want to draw a line that is perpendicular to the circle at this point. Because what a tangent is, it's a line that goes through a point and only one point on the circle. But we do know that where it goes through that point, it's perpendicular to the radius. So you'd want to do something like this. You'd want to create a line that, so make sure that this point is directly in between two other points in a line, and you would perpendicularly bisect. Because as soon as you get a right angle from the radius, you know that this is a tangent line and it only will go through one point. And here's the tangent theorem right here. I'll let you pause it and write it down. And when you're done, you can unpause the video and move on. So one of the things that we're going to do in class is we're going to prove something, but we're going to prove the radius and chord theorem. We'll do that in class, but you should just know what it is. Radius and chord theorem is essentially that if you know that you have a radius or diameter and it is perpendicular to a chord, so there's a right angle right here, you would automatically know that it splits the chord into two equal parts, or essentially the chord itself, which is AC, is bisected. Well, the opposite is true. The converse of the radius and chord theorem is if you know that this and this are equal parts of the chord, then you know that xb, if you knew x was the center of the circle, which would make x be the radius, then you would automatically then know that it had to have been at a right angle. Well, that helps us solve other problems, because in this case, based on this question, you would never actually been able to solve it unless you know two things. One, you would have to know that x is the center of the circle, which would make x be the radius. And two, you either have to know that DC is 8 or that there is a right angle. So we're just going to go ahead and assume for a second that there is a right angle. And once you know that there's a radius and a chord intersecting at a right angle, you would know that if this is 8, then this is also 8. Now, a lot of times you're going to be asked to find missing parts of the line. So right here is 2, and you would have to know the whole line. Well, you would need to know the radius of the circle. Now, one of the strategies that you can always utilize in the class is you can always draw in and connect 2 points. So because we know XB is going to be a radius, well, finding out what XC is will be helpful to us. So saying that, well, I'm going to move this over here. This is 8. I don't know what this is. But understanding that I would possibly know what y is if I was given the radius, it would help me be able to solve these problems. So in this case, you're not given what one radius is, but if you were told what xb equals, you'd be able to draw a line in here and you'd be able to create a right triangle because you would know this was 8, you would know what the radius was, but you wouldn't know what x was. Same thing goes over here. In the figure below, the radius of the circle is 8 units. Oh, sorry, let me move this. Oops, sorry. 8 units long, and the hypotenuse is 2 units longer than AB. Determine the length of AC and AB below. So it says the radius of the circle is 8 units. Well, that's this. Well, we can also say from C to this line is also 8. Now, what we don't know is the hypotenuse. The hypotenuse, the figure below, the radius of the circle, and the hypotenuse is 2 units longer than AB. So this is AB, so we don't know anything about AB, so we'll call that X. Well, this whole hypotenuse is 2 units longer. So instead of caring that this is 8, we're going to say that this whole line is x plus 2. Now, the reason why you're able to solve this is if you knew that this was tangent to the circle, you would automatically know that this is a right angle. So you could say 8 squared plus x squared equals x plus 2 squared. And just a reminder, when you do x plus 2 squared, it is a binomial. So you cannot just square the x and the 2. You'd have to do x plus 2 times x plus 2. And when you do that, you'd end up with x squared plus 4x plus 4, not x squared plus 4. And that's how you would end up solving. You would complete this. We're going to finish this up in class tomorrow, but that's just the basic background of what you would need for that problem. Right? This is a different kind of problem. It's asking you to find equation of tangent lines. So if I wanted to know the equation of a line that's tangent but goes through point E, there's a couple things that I would have to know. First of all, knowing that something's tangent means that we know that the line that's the radius of this circle. So it would be a straight line. Sorry about that. A straight line from the radius to point E. And we would need to know what point E is at. So point E is at, it looks like, it's hard to tell. It looks like this is the X and Y axis down here. So let's just go ahead and assume, just to show you how to do this kind of a problem, that this point E was 1, 2, 3, 4, 5, 6. I don't think it is, but 1, 2, 3, 4, 5, 6, 7, 8. So point E is at 6, 8. We'll just assume that for now. Well, we would know that a line that's tangent would be perpendicular to this line. So we'd have to find the slope of this line. So the slope of this line is up, we'll say 1, 2, 3, 4, 5, 6, 7, 8, and over 1, 2, 3, 4, 5, 6. So up 8 to the right 6 is a slope of 8, 6, which reduces to 4/3. So we would know that the slope of our new line would have a slope of the negative reciprocal of that, or negative 3/4, x plus b. And then a reminder of what we did in class, we'd have to take the point that we know it went through, which would be 6, 8, and we'd have to plug it into y and x in order to solve for b. And that would be able to give us the equation of the line that goes through point E. And that's essentially all the ones that you would do. I mean, you do that for every single point. All right? And that is just the background that you would need for SLT3. And then we're going to obviously teach the majority of it tomorrow. But just go ahead and rewatch that video just to get that foundation so that you're ready for class tomorrow.